very much like for it to happen because, as you said, it would simplify a lot of things. But in the end, the simulated data still does have a lot of weaknesses. So yeah, in order for it to at least be somewhat viable, we first have to qualify it against real world data. So you already have a need for real world data for the qualification, either for the simulation tool, uh, and then this requires much more data, or to validate the created simulation data before it. So from a tool that might be not qualified itself, but you can still qualify the data that comes out of it by comparing it again to the real world data. So yeah, I think we will not get rid of real world data anytime soon, but yeah, with the quality of simulations, we it they might play a bigger and bigger role, basically a bigger chunk of it in the entire data sets. But also one thing that makes, in my opinion, a difference is which part of the AI lifecycle the synthetic data is used. So in the test and validation, it makes much more sense since it's already been trained. If it's already been trained on a combination of synthetic and real world data, but in the training itself, I do not think we can replace it simply because of the nature of the ML models. So they tend to take shortcuts in learning. So, for example, if you have a simulation that has some let's say two perfect annotations or two surfaces that are too smooth. So in these cases, the LLMs take to, sorry, not LLMs, the neural networks tend to take shortcuts and then maybe learn by surface instead of learning by shape, which would happen in a naturally annotated data. Or maybe the annotations themselves get too perfect, so they learn on particular rendering type or a shadow, let's say, something like that. So yeah, this then makes a huge difference. And in testing, as I said, if you have already trained on features that came from a real sensor with some deviations in annotation, then you might, let's say, use the simulation to generate those cases that are either prohibitively expensive or dangerous to actually record in real world.
I mean, the improvements done last 5 years are massive, right? And high fidelity we see today is even hard to compare what we had just a few years ago. However, I would say that the main challenge still remains open, like how to make models more realistic in a sense that to be less perfect, and how to prove and when to decide that some parts will be tested only in simulation. Like in my opinion, here we also see another flavor of the same issue, like the level of understanding how AI models reason or think. Like once we understand that better, then we will might have a chance to build even better synthetic test data because weak spots then will be more clear to us. I mean, what's interesting, even if you look like, as we mentioned, latest NCAP tests, some scenarios like head-on oncoming vehicle scenarios, if you're familiar with the NCAP test scenarios, are really tricky to execute on a test track. And regulators are willing now to accept simulations as part of the proof. So I would say the future is more and more in simulations. There is no doubt in that. But the question is where we will completely switch and if we will ever completely switch.